Okay, so in this problem, we're being asked to use the four-step process to find the derivative of the function r, which is defined by this rule. So we need to set up the limit of the difference quotient, but instead of using the letter f to identify the function, we're going to use a lowercase r because that's how our function rule was defined. So we're going to find r of x plus h minus r of x and then divide by h. Okay, so setting up this limit was calculus. Now we're going to do a whole bunch of algebra to find this different quotient and then simplify it. So let's start by finding r of the input x plus h. So we're going to take our function rule here and do some side work. So our function is defined to say if you input an x into the function, you follow the calculation 9 minus 5 times that input squared. So to generalize it, whenever we input something to this function and we follow order of operations, we're going to do exponents first. So whatever the input is, we're going to square that input. Then the result is going to get multiplied by 5. Then the entire result is going to be subtracted from 9. And we are going to input the binomial x plus h. So we're going to do 9 minus 5 times the binomial x plus h squared. So according to PEMDAS, we need to do the exponent first. Well, the exponent is telling me I have the binomial x plus h as a factor 2 times. So I'm going to write that out. That's going to be 9 minus 5 times x plus h times x plus h. Okay. And you can multiply these binomials any way you want. You probably learned FOIL, so that's what I will use. So r of x plus h is going to equal to 9 minus 5 times the result of FOIL. Okay, so first times first, x times x is x squared, plus first times last, x times h. I'm just going to write that side by side as xh. Then inner times inner, h times x. Order doesn't matter when we multiply. So instead of writing that as h times x, I'm going to write that as x times h so I can see my like terms a little bit easier. And then last times last, h times h is going to be h squared. Now I'll just combine these like terms. If I have 1x plus h and I add another one, those are going to combine to 2xh. So I really have 9 minus 5 times the entire trinomial x squared plus 2xh plus h squared. So now at this point, I can distribute the 5 into those brackets. I can multiply all 3 terms of that trinomial by 5 and then subtract, or I can do it all at once, and that's what I'm going to do. I'm going to subtract all 3 terms of that trinomial and multiply all 3 terms of the trinomial by 5 at the same time. Okay, so we have our 9, and then I'm going to subtract 5 times x squared. So I'm going to subtract 5x squared. Then I'm going to subtract 5 times 2xh. So I'm going to subtract 10xh. Then I'm going to subtract 5 times h squared. So I'm going to subtract 5h squared. And there are no like terms. I can't combine or anything or simplify this expression anymore. So I'm going to come back up here to my difference quotient. And I know that r of x plus h is equivalent to these 4 terms. So I'm just going to replace the r of x plus h in my difference quotient with these 4 terms we got algebraically. Okay, so I'm replacing r of x plus h with 9 minus 5x squared minus 10xh minus 5h squared. Okay, now we still need to subtract r of x. That was our original function. So our original function, r of x, is equivalent to this binomial. So I'll replace the r of x with that binomial. And when I do that, I'm going to write the binomial grouped in either parentheses or brackets because I need to subtract every single term of that binomial. So I need to subtract the 9 and I need to subtract the minus 5x squared. Okay, so when I subtract the 9, that just gives me minus 9. And then when I subtract a minus 5x squared, That's going to change it to adding the 5x squared. Okay, so now we can just combine some like terms. We can keep cleaning up this rational expression. I had a 9, and then later I subtracted 9. So that is going to combine to 0. Those will go away. And I had a subtracting 5x squared, and later I added a 5x squared back on. So those are also going to combine to 0. So that tells me that my derivative is really just the limit as h goes to 0 of negative 10xh minus 5h squared, all divided by h. So at this point, I can try to do calculus if I want. I can plug in h equals 0. So wherever I see an h, I'm going to input a 0. But if I do that, I'm going to end up with a 0 over 0 scenario. That's a case 2 scenario that says we need to simplify that expression further and then plug h equals 0 into the simplified expression. So the algebra is not done yet. Let's go ahead and simplify that expression. And I'm going to do that by factoring an h out of each term of the numerator. So my derivative is really going to be the limit as h approaches 0 of, let's see. Let's factor an h out of the numerator. Okay, if I factor an h out of the first term, that'll leave me with a minus 10x. And if I factor an h out of the second term, that'll leave me with just a 5h. So I'm going to be subtracting 5h there. Okay, now my h's can divide out to 1. So I'm really just finding the limit as h approaches 0 of negative 10x minus 5h. That's my simplified difference quotient. So now we'll go ahead and I'll do the calculus, right? We're finding the limit. The calculus is happening. We're going to plug in h equals 0. So where I see that h, I'm going to input a 0 there. Okay, so what does that give me? That gives me negative 10x minus 5 times 0. Okay, well, 5 times 0 is just 0. So I just really have minus 10x, negative 10x. And what is that telling me? Well, that's the limit is when that difference quotient approaches 0. So that is my derivative. I am saying that the derivative of the r function is negative 10x. Now, you've learned some rules. You've learned the power rule. The power rule lets us skip all this 4-step process and go straight to this derivative. Okay, so let's just do that real quick to check our answer. Now, since we were asked to use the 4-step process, I have to show all these steps to get credit. But now that you know the power rule, you can at least check yourself. If we weren't told to use the 4-step process, then we could use the power rule to go straight to our answer. Okay, so let's go ahead and check using our power rule. Okay, the original function was r of x is equal to 9 minus 5x squared. So when I apply my power rule, I'm going to use my derivative notation. And then our first term in my binomial is a constant. We know that the derivative of a constant is 0. Because a derivative is a rate of change and a constant doesn't change. So the derivative of a constant is 0. We don't have to apply the power rule, but if you wanted to, you'd have to rewrite the term 9 to have a base with an understood exponent. So there's technically a base x of degree 0. A constant is degree 0. And then if we had tried our power rule there, our power rule says to multiply the exponent times whatever's in coefficient is in front of our base, but 0 times 9 is 0. So even if we completed our power rule, even if we rewrote the base and we decreased the exponent by 1, that'd give us x to the negative first power, and we times by the derivative of the base, which happens to be a 1. If we did all of that, I don't care what all this other stuff is. If we're multiplying by 0, the whole thing is going to be 0. So you can either memorize the derivative of a constant is 0, or you can do the power rule. Either way, you're going to get that the derivative of 9 is just 0. But I do need the power rule for the second term here. So my power rule says I'm going to drop the exponent down and multiply it to that coefficient, 5. So 5 times 2 is 10. So I'm really subtracting 10. And then I rewrite my base, which is an x. So I'm going to rewrite the x there. I'm going to decrease my exponent by 1. So 2 minus 1 gives me an exponent of 1. And then I need to multiply by the derivative of whatever the base was. And the base is just a plain x. And we know the derivative of a plain old x is just 1 because it's a linear function, y-intercept 0, slope of 1. So we know that derivative is just going to be 1. And we don't write this understood exponent of 1 because that could really get confusing. That could look like a prime. So we don't even write that. So when we do all this, what do we get? We just get that the derivative is equal to 0 minus 10x, or just negative 10x, which is the exact same answer we got when doing our 4-step process. Okay, now when students typically struggle with the 4-step process, it's usually with the algebra. It's usually with finding the difference quotient and then simplifying the difference quotient. It's not with these calculus concepts of limits. So if you're struggling with the algebra, find a tutor, get help from a classmate, come to me during office hours, visit our embedded tutor. There are lots of instructional associates that can help you with algebra. There are tutors in the learning lab. So reach out for help if you need to dust some cobwebs off that algebra, and same thing for the calculus. Math is a language, you got to talk it out. Okay, so good luck with this 4-step process. Write your work carefully so you can get partial credit. Get help with algebra when you need it.